Hi everyone, welcome back to another tutorial in a series of our Algebra 1 topic. So today we will be discussing exponents, constants, terms in algebraic expression, and we will be taking a lot of examples. So as you can see on my screen, an algebraic expression is any combination of algebraic notation to represent a number. So what that means is that if I write any kind of expression, it could be anything at all, say 6m raised to the power 4 n plus 7a squared b plus say 3, for example. As long as you are willing to assign a number, or as long as you could assign a number, any number to each of the letters, say m is equal to 1, n is equal to 3, a is equal to 7, b is equal to 8, it doesn't matter. When you substitute these letters by these numbers and you add up everything, you will definitely arrive at a number. Say for example here you arrived at 53. That's what that definition means. An algebraic expression is any combination of algebraic notation to represent a number. This expression that I have written here, right, represents 53. The only reason why it was in an expression form like this is because it was not assigned a number, but now we assigned m to be equal to 1, n is to be equal to 3, and so we eventually found the number it represented, which in this case is 53. So for the second term, every component of an algebraic expression is referred to as a term. So for example, we say 6m n plus 7a squared b plus 3, right? This is referred to as a term in this algebraic expression. This is another term, and this is definitely another term. But because this is a number and it is standing alone, we refer to it as a constant. So that said, let's move ahead. There's also another term that is called exponent, right? Exponent is simply the same thing as power. We discussed power in our last class, and it is that little number that is written above and just after the letter we are talking about. So say for example, we have a term 7a squared k, right? This little number here 2 is referred to as exponent, right? Sometimes it is referred to as power. And like I said before, what's a constant? A constant is a number occurring by itself in a term or an expression, right? So a number occurring in a term or expression when it is considered by itself. So for example, in this one that I wrote here, in this term, this algebraic expression that I wrote here, 3 is standing by itself, so it's a constant. 7, when you consider it alone, is a constant. 3 is a constant as well. 6 is also a constant as well. So let's move forward. So just to kind of illustrate further, right? 7a squared bc. 7 is a constant. 2 is a power, or sometimes exponent. So even though it's not written there, b and c have a power, right? But it's just that it's not written there. It doesn't have to be written, right? It can be inferred. So b is the same thing as b raised to power 1, and c is the same thing as c raised to power 1, right? So there's a power 1 here. This is as well a power, and this is as well a power. And a, b, and c are all known as letters, or more appropriately, when you guys go advanced, or when we start talking in advanced terms, right, or when we get to more advanced aspects of algebra, they will be known as variables. And they are known as variables because a variable is just an unknown or a letter that can be assigned several values. In other words, some other persons can come to say, I want my a to be equal to 3. Some other persons would say, I want my a to be equal to 10. So it can take on any value or any number. So all these a, b, and c are variables, and all of this by itself, 7a squared bc, is referred to as a term. So let's go to case 1. So there are two main ways by which algebraic expressions can be represented, right? And case 1 is expressions with similar term. So a similar term has same letters and same exponents. So what that means is that if you look at group 1, let's refer to everything here as group 1, and let's refer to everything here as group 2 of group 2, or group of terms 1, group of terms 2. So now we say similar terms have the same letter and the same exponent. If you take a look at A, right, you would see that M has 2 as its exponent, N has 4 as its exponent. In this other one as well, B, M has 2 as an exponent, N has 2 as an exponent. If you look at this one, the third one as well, which is C, M has 2 as an exponent, N has 4 as an exponent. So a direct would I say consequence, or a direct thing that can happen to group 1 is adding them. So we're saying add group 1, and that would be 10m square n4 plus 1 over 4m square n4 plus minus m square n4. So that means we want to add this. Now the reason why we can add them is because they have the exact same letters and the exact same exponents. Exact same letters, exact same exponents, right? So we can say, we could, if we want, factorize the letters and the exponents out. So that means that this would be 10 plus 1 over 4 minus 1, right? And it's minus 1 here because plus times minus is definitely minus. So because m square n raised to power 4 is common to all, we can write it outside of the bracket. When we add this together, we can okay, here, sorry, just give me a moment. I'm just going to add one more note, one more section after this. Yeah, so that would be 10 minus 1 over 4 plus 1. So when we find the LCM of this, just so that we can add this together, right? So 10 divided by 1, 1 divided by 1, right? So 1 into 4, 1 goes into 4 4 times. 4 times 10, that's 40, minus 1 goes into 4 1 time, 1 times 1, 1 goes into 4 4 times, 1 times 4 4, right? So when we add this up together, that will become 40 minus 1 plus 4. That would be 39 plus 4. That would be 43 divided by 4, right? So that becomes 43m square n raised to the power 4. That's the final expression we get when we simplify the first one. So now let's go to the second one. Let's go to the second one, which is, the second group, right? That second group is to actually, I think I want you guys to use that as a practice. Pause the video now and see if you could add group 2. This group. Add group 2, simplify, and let's see what you come up with. Pause the tutorial now and go through with that. Let's see. Okay, welcome back. So let's do this. A square BC plus minus 7 8 it's a squared bc. So a squared bc minus 7a squared bc plus 8a squared bc. Again, they are all the same. A has an exponent of 2, b exponent of 1, c an exponent of 1. It's the exact same as these other two, so we can add them together. So that means 1 minus 7 plus 8, because they are all similar and common to all these three terms, right? So that would be a squared bc. So 1 minus 7 is minus 6 plus 8, so that will be 2a squared bc. So this is the final term, or the simplified term for this. Again, remember, because they are similar terms, we are able to add them. So let's go to case 2. Case 2 is a situation where we have different or dissimilar terms. So dissimilar is really nothing but the opposite of similar, right? And it's just a fancy word for different. So the expressions in this case are different. Let's see how we would treat this. For example, there's an a here, or letter a, right? The exponent is 2. There's a letter b, the exponent is 1. There's a letter c, the exponent is 2. There's a letter d, the exponent is 2. There's a c, there's a d, and there's an 8, which is a constant. 7 is a constant as well. So because all these terms are not similar, because the letters and the exponents are not similar in this term and this term, and this term and this term, they're all different. So there's really nothing we can do. We cannot simplify further. We just have to leave our final expression as this. The exact same thing is happening to this, right? So yes, that's it. That's how you treat dissimilar terms. You really don't have to do anything, because the terms, the individual terms or the component terms, are not similar. So let's go to degree. Let's understand what the term degree means. The degree of a term is the sum of the exponents of the letters or unknown in the term. So for example, we say find the degree of each of the term below, right? So I'm going to start with a. Seven x cubed y raised to the power 5, right? So it says that the degree is equal to exponent of each of the letters or unknowns in the term. So in this case, exponent of x plus exponent of y. Degree is equal to exponent of x plus exponent of y. Again, like we explained, what is the exponent of x? In this case, it is 3, right? What is the exponent of y? In this case, it is 5. So we just add both numbers together and we say that the degree of this term is 8. So same thing applies to b. Okay, so just pause the video now and see, maybe you are able to determine the exponent of, the degree of question number b. Okay, so question number b says 2xy. Again, remember what we said earlier, right? There's an invisible one here, because x raised to the power 1 is the exact same thing as x, is the exact same thing as x, and x raised to the power y is the exact same thing as y. So that means the degree of this one will simply be degree exponent of x plus exponent of y. So that would be 2. And for the third one, 4x squared y, right? The third one is 4x squared y. So the exact same process, right? Degree is equal to exponent of x, which is 2, plus exponent of y, which is 1. And the degree of that term, 4x squared y, is 3. So a few notes for you guys here, right? We say here that the degree of a constant is 0. And why we're saying that is this. We'll explain, right? So what's a constant? Like we said, a number appearing in a term when considered by itself. So for example, like I said before, if we look at the term 6x cubed y raised to power 1 or y raised to power 10, right? The constant here is 6. So now we want to determine the degree of the constant. if it occurs by itself, right? The degree of that constant. Say we're saying what is the degree of the constant 6. Again, remember that 6 is equal to 6 times 1, right? So technically I haven't changed anything there, right? So again, 6 times 1 we can rewrite as 6 times x raised to power 0. And the reason is simple, right? X raised to power 0 is equal to 1. It's always equal to 1, irrespective of the number that you assign to x. As long as you are raising it to 0, the answer would always be equal to 1, right? So again, how do we define degree? The sum of the exponents of all the letters in the term. So the term in this case is x raised to power 0. So the sum, since there's only one letter, right? The sum of 0 will always be equal to 0. And that's why we say the degree of a constant is always equal to 0. So the second thing that I would really like you to note is that 0 is the only term with no degree. And the reason is because 0 is equal to 0 times x, right? And we know that anything you multiply by 0, irrespective of how big or how small that number is, multiplying it by 0 will always be equal to 0. So there's really nothing to kind of look at, right? Because 0 is equal to 0. There's really nothing to look at. There's no letter to consider its exponent, right? So for that reason, 0 is the only number with no degree. So if you do not understand or you require more clarification for any part of the tutorial that we've had today, please put it in the comment. Let me know and I'll be sure to re-explain in subsequent videos. I hope you guys have enjoyed the content. If you have, please share the video, give the video a thumbs up, right? Please subscribe to the channel to join our amazing community of math loving people. Don't forget to click on the bell icon so you'll be the first to know when we upload a new video. Thank you very much for joining in today. Thank you very much for watching the video. Keep learning, keep solving math, and keep growing your math skill. Okay, just before we go, I have a take home for you, right? These are really, really very, very simple, right? Everything you need to solve these exercises, they have been taught in this tutorial. So go over the tutorial one more time or two more times so that you can get the concepts down. And also I have put the description. I'll put the answers to this in the description section below this video. Thank you and take care.